Okay, now let's do a little more complicated example. We're trying to find the definite integral of e to the 2x minus 1 from 0 to ln of 2. Okay, and we want to find it in a connection with its area and the region that it creates with the x-axis. So first, it's best if we graph e to the 2x minus 1. And e to the 2x minus 1 looks like e to the x, right? But just lowered by 1 because of this minus. So in the graph, this point here used to be the point 0, 1, and now it's the point 0, 0. And then we're going to stop it at ln of 2. And if you plug in ln of 2 to that formula, you just get 3, right? Because it's going to be e to the 2 ln of 2, which gives you e to the ln of 4, which gives you 4 minus 1 equals 3. Okay, so the real goal is to find the area down here. And you notice that your function in this interval is greater or equal to 0. And when that is the case, the area corresponds to the definite integral. So our task is to find from 0 to ln of 2 of e to the 2x minus 1 dx. And again, the easiest way to do that is to find an antiderivative of e to the 2x minus 1 and use the fundamental theorem of calculus. Now, I claim that the antiderivative of e to the 2x minus 1, which we can use, is this guy. It's e to the 2x over 2 minus x. And this goes from 0 to ln of 2. Why is that the case? Well, of course, the antiderivative of minus 1 is minus x. That's easy. Why the antiderivative of e to the 2x is e to the 2x over 2. So let's spend just a second for this. I'll prove it by just taking this e to the 2x over 2 and find its derivative. And you'll see that this is just e to the 2x. To take the derivative here, what you get is derivative of e to the 2x over 2. And derivative of e to the 2x is e to the 2x times 2x derivative. So it's just e to the 2x times 2 over 2. It's e to the 2x. Kind of reminds us the power rule when you need to pre-divide with 2 to get rid of the extra coefficient that you're going to get when you're taking the derivative of e to the 2x, right? In any case, that's how you find the antiderivative of e to the 2x. And now by using the fundamental theorem of calculus, the only thing you need to do is plug in those two numbers in here and take their difference as follows. So I'm going to continue down here. What we get is e to the 2 ln of 2 over 2 minus ln of 2. That's your first term. Minus e to the 2 times 0 over 2 minus 0. That's your second term. So now let's do the computations. It's best if you rewrite this as e to the ln 2 squared. I move the 2 on the exponent, all over 2 minus ln of 2. And here notice that it is e to the 0, and that's always equal to 1. So this is just minus 1/2. All right, now e to the ln 2 squared, the e and the ln cancel out, and what you get is 2 squared, which is 4 over 2 minus ln of 2 minus 1/2, and I can just get rid of the parentheses, right? So 4/2, that's a 2, but there's a minus 1/2. So what you get is really 3/2 minus ln of 2. Okay, that's your final answer. That also corresponds to the area. So the area is 3/2 minus ln of 2, and the definite integral is 3/2 minus ln of 2.